Okay, so you guys just finished learning all about atoms and the structure of atoms and the periodic table and how that has to do with electrons. And now we're going to put all that knowledge together and talk about forming different types of bonds. We're going to start out lesson one with ionic bonds and metallic bonds. So the first thing is defining what a chemical bond is. It's a force that holds atoms together, basically. Could be atoms of the same type, like two calcium atoms, could be different atoms. They're going to be a charge between the positive nucleus and the negative electrons around it. Now, remember from last chapter, I said everybody wants that 8 valence electrons. They try to form the octet. That's what that is. It's arrangement of 8 valence electrons. Valence is just another way of saying outer electrons. Now, I showed you something called a Lewis dot structure, which is where you look at the periodic table and you figure out how many electrons something has based on what group it's on. So, for example, if I were to loosely draw a periodic table here, yeah, bloop, 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 yep, this is group 1, group 2, right there. Everything in this group has 1 valence electron. Everything in this group has 2, right? Then you skip over these guys over here, and then it continues down there. Now, an example of how we illustrate that is with a dot diagram. So here we have lithium, which would be in group 1. So we put 1 dot there to represent its outer electrons. Beryllium, group 2, 2, and so on and so forth until you get to our noble gases in group 18, which are the guys that have that full octet. They're special. Everyone wants to be them. And so things bond so that they can get that octet. Sometimes it's bonding through sharing. Sometimes it's bonding from gaining and losing, like what we're going to be talking about today. So when you have a positively charged atom, we call that a cation. Remember, whenever an atom gains or loses electrons, we call it an ion. If that ion is positive, we call it a cation. Important word. Now, this throws people off a little bit, but it makes sense. If you lose an electron, you become positive because electrons are negative, remember? So if I take away something negative, now I'm more positive. You can also think about it this way. So you have an illustration here. You have a sodium atom. It has 11 electrons, okay? And it has 11 protons because we know in a stable atom, the protons are going to match the electrons, no charge. If I take away one of those electrons, now I only have 10 electrons and 11 protons. So I have one more positive charge than I have a negative charge, meaning the whole atom is positively charged. It's a cation. So the opposite of that is an anion. That's a negatively charged ion. I apologize that the picture formatted weird here and there was no way for me to move it. But it's just a cloud. You could follow me here. This configuration down here, don't worry about that. That's something that you'll learn in chemistry. But this is just showing you groups of ions that typically form anions, things in groups 15, 16, 17, things that typically are going to want to gain electrons. So, for example, if I had a neutral chlorine atom, and we talked about our halogens in group 17, how they are just dying to take electrons because they only need one more. So originally it had 17 protons, 17 electrons. It was neutral. I add one more electron. Now I have one more electron than I have protons, one more negative charge than positive charges, meaning the whole atom is going to have a negative charge now. That is an anion. So when you gain a negative charge, you become negative. When you lose a negative charge, you become positive. So now I'm taking all that. What does it look like when we combine things? An ionic bond is when you have positively charged particles, so think anion and cation, that are going to be bound together based on their sharing of those electrons. One's giving, one's taking. It's binary if it only has two different types of elements. So for example, this calcium chloride down here, this is binary because it only has two types of atoms. Now there are three atoms here because there's two chlorines, but it's only two types. It's binary. When you get to chemistry, you'll learn about polyatomics that have a bunch of different elements in the same compound. What I want you to understand right now is how does an ionic compound form? So for example, let's say we wanted to do sodium chloride, which is typical table salt, right? NaCl. This is a sodium atom, okay? So we know our protons and neutrons are in the nucleus. They're only showing you the protons because it's the only thing that matters right now. Doesn't mean the neutrons aren't there, they're just not showing them to you. These are the electrons, these little gray dots around. Notice the one electron on the outer shell. This is chlorine. Notice the 7 electrons on the outer shell. So these guys are thinking, well, if I give you mine, chlorine, now you have 8 on your outer shell. And since I've lost mine, my next shell underneath becomes my outer shell. And there are 8 electrons there. So now we both win. Everyone has 8 electrons. These things are going to stay close by, though, because that electron still does belong to sodium. So they're kind of bonded together now. That is how ionic compounds form. This is an example of when you have just two different atoms. Over here on the left is an example of where you have 3 different atoms. So calcium here has 2 valence electrons, and so it wants to get rid of 2 of them so that it can go to that next level where it has 8. Chlorine still wants 1 more, but it doesn't want to give chlorine 2 because then it would have 9. That's not the goal. So it attaches to 2 different chlorine atoms, so each of them gets 1. Everybody walks away with 8. Everybody's happy, and you have your compound of calcium chloride. So now some properties of ionic compounds. As solids, they're pretty brittle, they're easy to break. They form this regular structure we call a lattice. The reason they're easy to break is if you look at this illustration down here, this is an example of how it would be structured. You have your positive and your negative charges interwoven. If you were to add some force, right, so they're using a hammer here, and those charges align, so now you have a positive next to a positive and a negative next to a negative, you know from electricity and from magnets that same signs want to repel. So those things are easily just going to break apart because those positives don't want to be next to each other and those negatives don't want to be next to each other. So ionic compounds are brittle solids. Because they're tightly compact as solids, they're poor conductors of electricity. Whereas in their liquid form, an aqueous solution just means that you have an ionic compound dissolved in water. So if they're in an aqueous solution or a liquid form, it's easier for electricity to flow because those electrons can kind of move around a lot more than they could in a solid. When you have an ionic solution that is conducting electricity, you can call it an electrolyte. So those are some properties of ionic compounds. Next, we have metallic bonds. And I mentioned this to you last chapter, this whole electron C model. What this means is that instead of, like we just saw with ionic compounds, where you have one gaining and one losing, these guys just throw all their electrons in together into the C. So these electrons can kind of float anywhere around here. This is what makes metals such good conductors, because if this were an ionic compound and you would just have positive, negative, it's going to take a lot longer for those electrons to move than this electron here can easily just swim its way all the way down here and conduct that electricity all by itself. Um, so that's what the electron C model is. Those electrons that are floating around are called delocalized because they're able to move away from their local area, the atom that they technically belong to. This is how metallic bonds form together. When it comes to ionic, you typically are going to have a metal with a nonmetal. So, like NaCl that we just looked at, right? That's going to be our group 1. This is going to be our group 17. So we know that's an alkali and a halogen. Metallic bonds are going to be formed with just different types of metals. So some properties of metals, we know that they're malleable, which means they can be formed into different shapes. We know they're ductile, which means they can be formed into wires. We learned that from last chapter. And we said that that was because of this electron C model. This is just an illustration showing that to you. When metals are bonded together, because those atoms are kind of in this C model, they can kind of just shift and change shape. The electrons can move around as opposed to the ionic compound we just saw. You could add force and then the like charges end up near each other and it breaks apart. Here, the like charges can kind of move where they need to be, so it's easier for them to form different shapes. And that is lesson 13.1.